Hello Algebra 1, today we're looking at Unit 6, Lesson 14, which is graphs that represent situations. Example 1, a jumping frog. The height in inches of a frog's jump is modeled by the equation h of t equals 60t minus 75t squared, where the time t after it jumped is measured in seconds. So number 1, find h of 0 and h of 0.8, and what do these values mean in terms of the frog's jump? So you'll plug in your 0 and your 0.8 for your t, and both of them equal 0. And that is because the frog is on the ground when t equals 0, which is before they jump, and when t equals 0.8, that is when the frog lands on the ground again. Number 2, how much time after it jumped did the frog reach maximum height? Explain how you know. So the frog reached its maximum height at t equals 0.4 seconds. And that is the halfway point of the jump. If we graph the function, the vertex of the graph will have the horizontal coordinate, or your t-coordinate, of 0.4. Example 2, the equation h equals 2 plus 23.7t minus 4.9t squared represents the height of a pumpkin that is catapulted up in the air as a function of time t in seconds. The height is measured in meters above ground, and the pumpkin is shot up at a vertical velocity of 23.7 meters per second. Without writing anything down, consider these questions. What do you think the 2 in the equation tells us in the situation? And what about the negative 4.9t squared? If we graph the equation, will the graph open upward or downward? Where do you think the vertical intercept would be, and what about the horizontal intercepts? The 2 tells us the pumpkin is 2 meters above ground before it is launched. The negative 4.9t squared shows the height lost due to gravity, like the negative 16t squared in the cannonball problem that we did last week. The graph would open downward. The height starts at 2 meters and then increases as the pumpkin is shot up, and eventually it decreases as the pumpkin falls back to the ground. The vertical intercept would be at 0, 2, because when t is 0, the height is 2 meters. And the horizontal intercepts are hard to tell without graphing or having the equation in factored form. One of them will be about located around 5, 0, because substituting 5 for t gives a height of negative 2 meters, which is pretty close to 0. So number 2, graph the equation using graphing technology. I went to Desmos and graphed it, and this is what it shows us. 3, the vertical intercept is 0, 2. It tells us that the pumpkin's initial position is 2 meters above ground. The graph intersects the horizontal axis around negative 0.8 and 4.9. The positive horizontal intercept tells us that the pumpkin hits the ground after about 4.9 seconds. The negative intercept doesn't have any meaning here since the time cannot be negative in this case. The vertex is at approximately 2.4 and 30.7. It tells us that the pumpkin reached its maximum height of about 30.7 meters around 2.4 seconds after being fired. Looking at example 3, here's a graph that represents the height of a baseball h in feet as a function of time t in seconds after it was hit by a player A. The function g defined by g of t equals negative 16t minus 1 times t minus 4 also represents the height in feet of a baseball t seconds after it was hit by player B. Without graphing the function g, answer the following questions and explain or show how you know. So number 1, which player's baseball stayed in flight longer? So player A's baseball stayed in flight longer because the zeros of function g are 4 and -1/16. The -0 doesn't have any meaning in this situation. A 0 in this situation means the time when the baseball has a height of 0, or when it hits the ground. For player B, this happened when t equals 4, or 4 seconds after it was hit. Player A's baseball hit the ground a little over 5 seconds it was hit. Number 2, which player's baseball reached a greater maximum height? Player A's baseball, because from the graph for player A, it looks like the y-coordinate of the vertex is around 105 feet. For player B, the vertex of the graph has a t-coordinate of about 2, which is halfway between -1/16 and 4. We can find g of 2 to estimate the height at that point, which is approximately 66, so the highest point of player B's baseball was around 66 feet. Number 3, how can you find the height at which each baseball was hit? For player A, we can look at the y-intercept of the graph, and for player B, we can find the height when t equals 0. So you would plug in 0 for t and solve it, which gives you 4. So it was hit at 4 feet.